Okay, so calculate the volume of hydrogen produced at RTP when a concentrated aqueous solution of sulfuric acid is electrolyzed for 15 minutes using a current of 1.4 amps. Okay, first thing we've got to do is to use the data we've been given. We've been given time, 15 minutes, and we've been given current of 1.4 amps. Then what you're going to do, you're going to be using your relationship between those, current, time, and charge, which is current equals Q, which is our symbol for charge, over time. You'll have to reorganize that to get charge as your relevant quantity. So that would be current times time. And you have both those values. It's giving you a current of 1.4 amps. Whoops, terrible writing there. Times the time, it's giving you time here, but it's giving you time in minutes, okay? Now the time you need to record is going to have to be in seconds, so you need to do 15 times 60 there, okay? So 15 times 60, because your time must be in seconds. That'll allow you to calculate the charge. Remember, charge is in coulombs, okay, with symbol C. So this should be C. And obviously you're allowed a calculator in these exams, and that you should get an answer there of 1260, if my math is not wrong. Again, unit coulombs. Now it's really, really important to have the charge, because we can use Faraday to work out the number of moles. So from this we can calculate the number of moles of electrons involved. And Faraday's constant tells us, I'm just going to put FC, okay, Faraday's constant tells us that 1 mole of electrons has a charge of 96,500 coulombs, okay? And we have a value for coulombs here, so we can now use this value to find out how many moles of electrons were involved in the 15 minutes that our electrolysis was set up for. So this is quite simple. You're going to do 1260 divided by Faraday's constant, 96500, and that's going to give us the number of moles of electrons involved in our electrolysis setup. The answer here is 0.013, okay, to 3 significant figures. So effectively, this is the amount of moles of electrons that have been pushed through this electrolysis setup by the battery in that time period, okay? That's what this value really means. That many electrons have been pushed through this system in over 15 minutes of time. So now what we need to do is to go back to our kind of molar quantities and relationships here from this half equation. Okay, remember we're talking about how much hydrogen has been produced. Okay, so we're interested in this half equation here. Okay, I'm just going to write that out again. We had 2H plus 2 electrons to make H2, okay? Now it wouldn't matter if you used this version or the one that was multiplied by 2 here, which would be the correct version when you've got your full redox equation, if you see what I mean, okay? Because you've got 4 electrons being lost on the hydroxide here, where I've got my cursor there, then you'd obviously need 4 electrons to be gained here. But because we're talking about ratios here, it's actually not relevant. I don't need to, okay? But I could easily have this doubled up to 4H plus 4 electrons to make 2H2. It would be absolutely fine. Okay, so what is important to understand here is for every 2 moles of electrons that we have, according to this balanced half equation, we are going to produce 1 mole of hydrogen gas. So we're 2 moles of electrons produces 1 mole of hydrogen gas. Now we're not used to talking about moles of electrons, but we've got to start getting used to that now. So it's a 2-to-1 ratio. But we don't have 2 moles, we actually have 0.013 0.013 moles, okay? So 0.013 moles will produce half of that, okay? So 0.013 divided by 2, okay? Because of the 2-to-1 ratio. So for this many moles of electrons, we will be producing this many moles of, sorry, this should be a 2, of hydrogen gas, of H2, okay? Now it's asking you to calculate the volume, okay? So it wants the volume, and it's put in here that we were talking about room temperature and pressure, and normally the question here will probably also say something like 1 mole of gas occupies 24 decimeters cubed, okay? So that's all you're going to need to do. What is 0.013 divided by 2? 0.013 divided by 2 equals 0.0065. And then quite simply, if 1 mole of any gas occupies 20 decimeters cubed, then 0.0065 moles will occupy this amount, okay? So we'll do that times 24 equals 0.156. 0.156, and remember, unit here will be dm cubed. So hopefully that has all made sense. Let's just quickly recap what we did. First of all, we used the available information to us using the relationship between current, charge, and time in order to calculate the charge in coulombs. Then we used the idea of Faraday's constant to work out how many moles this charge relates to in terms of the electrons. And we worked out that we had 0.013 moles of electrons flying through this circuit, you could say, in that 15 minutes of time. And then we used the balanced half equation for the hydrogen, because that was what we're interested in order to calculate the molar relationship between the number of electrons and the actual amount, the number of moles of hydrogen produced, okay? And then that was just quite simply a scaling down there, okay? Because for every 2 moles of electrons produce 1 mole of hydrogen gas. And then all we had to do then is to use our Avogadro's gas law, basically, there, in order to work out what volume that would represent. Hope that has all made sense. Bye-bye.